Hello guys, welcome to this video. Today we're going to be talking about the histological structure of the heart wall. So we all know that the heart is mainly a muscle. So it has a very thick layer of muscle, but if we look at its histological structure, we find that it actually has 3 layers. So we have the innermost layer, so you gotta know that this is the inside of the heart, and this is the innermost layer. It's called the endocardium, and then we have the middle layer, which is the myocardium, and then we have the outer layer, which is the pericardium. So let's start with the pericardium. So the pericardium itself has 3 layers. So just you gotta know that this is the pericardium, and it has 3 layers. So we have, first of all, on the outside we have the fibrous pericardium, which is a very thick fibrous connective tissue with a lot of collagen fibers. And then we have these 2 layers, which are part of the serous pericardium. So these 2 layers, the outer one is called the parietal layer of the serous pericardium, and the internal one, so this one, is the visceral layer. So the visceral layer, we call it the epicardium, okay? And between the 2 layers of the serous pericardium, so between the parietal layer and the visceral one, we have this cavity, which is a very, very thin cavity. It's called the pericardial cavity, and it contains a small amount of serous liquid or fluid that allows the sliding of the heart when it contracts. So yeah. So now let's look at the histological structure of the parietal and the visceral layers of the pericardium. So these 2 layers are very similar in their histological structure. So they have basically the same layers, and then so what we see in this picture here. So what we see here. So this is the epicardium. So this is only the visceral epicardium. So this is the cavity, and then on the outside we have the parietal epicardium. So it has 3 layers. So from the outside we have the mesothelium. It is in contact with the pericardial cavity, and it's a simple squamous epithelium. So yeah. And then we have a submesothelial layer, which is a connective tissue with a lot of elastic fibers. And underneath that, so we have a subepicardial layer, which is very rich in fat tissue. So it's an adipose tissue. So this layer allows the junction with the myocardium underneath. So yeah. So this structure goes with both the parietal and the visceral epicardiums. Now let's go and look at the myocardium. So it's the thickest layer. It's this layer of muscle. So it's the thickest layer, and it's particularly thick in the ventricles and even more thick in the left ventricle. And it makes sense because if you think about the atriums, they contract to propulse blood from the atriums to the ventricles, and the ventricles are right next to them, so they don't really need a lot of force. But on the other hand, the ventricles have to eject the blood into some vessels, and they're gonna go in the periphery, so they need a lot of force. And for the right ventricle, it needs to eject blood into the small circulation. But the left ventricle needs to eject blood to the big circulation, which reaches every part of our body, even our very big toe, which is very far from the heart. So as you can imagine, the left ventricles needs a lot of power and force of contraction to be able to propulse blood. And the pressure that comes from the ventricle is even present in the veins. So in a way, the left ventricle propulses blood back to the heart. So this enters into physiology, but still it's very strong. So as you can see here, that this is the right ventricle. Its wall is pretty small. I mean, it's pretty thin compared to the left ventricle, which is very thick. So yeah. Now, inside of this muscular tissue, so this muscular tissue is a little bit particular. So in muscular tissues, we have three types. So we have the skeletal muscle, and then we have the smooth muscle, and then we have the cardiac muscle. So the cardiac muscle is striated, and its contraction is automatic, and it's rhythmic, and it's involuntary. So it kind of like has things in common with the smooth muscle and the skeletal muscle. And it contains three types of cells. So we have the cardiomyocytes, which are the main cells. So these are the cells that contract. Okay. And then we have the pacemaker cells. So these pacemaker cells are, super important because these are the ones that give the automatic feature to the heart. So these are able to create an action potential by their own. So they don't really need, they're the pacemakers. So they don't really need another cell to tell them to create the action potential. So these are special cells. And then we have the myoendocrine cells. So these are cells that release a specific type of hormone. So let's look at the cardiomyocytes. So I'm actually gonna make another video where I talk in in a lot of details about what's inside of this cell. But all you gotta know for now is that these cells are branched. So you can see this cell right here. It has two branches like this. These cells usually have one nucleus or two at most, which is very different from the skeletal muscle cells that have a lot of nucleus. Okay, so these ones have only one or two, and they are attached to each other. And you can actually, when you look at the structure, when you look at a microscope, you can actually see these like lines between the cells. So these are the intercalated discs. So there are a lot of junctions between the cells. So I'm going to talk about this in detail in another video about these cells specifically. So yeah, so these are the main cells. They contract, and yeah. Now for the pacemaker cells. So the pacemaker cells are, kind of like a specialized cardiomyocyte. So originally it was a cardiomyocyte, but then it changed into a pacemaker cell. So it kind of looks like a cardiomyocyte, but it doesn't have those myofibrils that contract. So it has very, very few of those, and it doesn't really contract, but it rather, creates the action potential and then transmits it. Okay, and we have the cells in the SA node, and then we have the ones in the AV node, and the ones in the bundle of His, and the Purkinje fibers. So yeah. And now we have a third type of cells, which are the myoendocrine cells. So these cells are mainly present in the atriums. So we find them in the atrium walls, and these are cells that have these granulations, like these dark points, which contain a certain type of hormones. It's called the ANF, or ANP. So that stands for atrial natriuretic factor or peptide. So this hormone, the release of the hormone is activated when there is an abnormal stretch of the atrium. So when the atrium walls are too stretched out. And when does this happen? If this happens, that means that there is an excessive volume of blood, and that will cause the increase of the blood pressure, and we don't want that. So this hormone will act on this. So on one side, it will go to the blood vessels, and it will cause a vasodilation, which will decrease the resistance in the blood vessels, and it will, compensate for the increase of volume. So it will get the heart pressure back to normal, and then it will also go to the kidneys, and it will act on the distal convoluted tubule of the kidney, and it will, increase the release of water and sodium and potassium. That way we will get rid of that excessive volume of blood. Okay, so yeah. Now let's go to the very last layer, which is the innermost layer. It's the endocardium. So here is the endocardium. So it has 3 layers. So it has a layer of epithelium, and then two layers of connective tissue. So the first layer is the endothelium. So it's a simple squamous epithelium. It's actually the same epithelium that you find inside of vessels. So yeah. And then you have the subendothelial layer, which is just underneath. So this is kind of like the lamina propria of any epithelium out there. So it's a connective tissue with some elastic fibers, etc. And then we have the subendocardial layer, which is a connective tissue that allows the junction with the myocardium, and it also protects the endocardium, so that when the myocardium contracts, and the contractions of the myocardium are very strong, this will allow, this will protect the endothelium from those contractions. So I think this is all. Oh, I forgot one detail about the myocardium. I talked about the 3 types of cells inside of it, but there is, around these cells, there is a little connective tissue. It's called the endomysium. So it's spelled like this. Okay, so it's connective tissue between the cells, and it contains the blood vessels that give the blood supply to these cells. So I think that's it about this, the histological structure of the heart wall. I hope this video helped, and please don't forget to leave a like and to subscribe for more videos. And yeah. Thank you for watching, and have a nice day.